Okay, for set A, find 65 times 10 to the third. So it says look at the exponent for the power of 10, and it uses the word annex, which is kind of add the number of zeros to the other factor to find the product. All right, let's put that in terms of something that's easier to understand. The way I explain it, for a problem like number one, 12 times 10 to the fourth literally means 12 times 10 times 10, sorry for my handwriting, I'm using a mouse again, times 10 times 10. So every time I multiply by 10, it's like adding let me put that, that's number one. So 12 times 10 to the fourth is the same as just adding a zero to the end of your place value. So 12 times 10 to the fourth is the same as taking 12, multiply that by 10, adds a zero, multiply that by another 10, adds a zero, multiply a third 10, adds a zero, multiply it by 10, adds a fourth zero, so you have 120,000 as your answer. For number two, it's 100 times 815. Okay, so for that, I would start with 815 and add to that two zeros because 100 is 10 times 10, so two zeros. So 815 with two zeros behind it is equal to 81,500. For number three I'll do in green, is 10 squared, or 10 to the second power, times 39. Okay, so I'm going to start with the factor that's not a power of 10, so 39 is just 39. Times 110 would be 390, but there's two tens, so 10 times 10 would be two zeros after it, so that would be 3,900. And for the last one, which I will do in blue, it's 6,471 times 10 to the first. Well, 10 to the first just means times 10. So this would be like adding one zero at the end. So 6,471 with one zero at the end is 64,700. And pardon my handwriting, let's fix that. 710. 64,710. So hopefully that makes sense for set A. For set B, right? Set B is, the instructions say estimate 37. Let's change that to a highlighter. Estimate 37 times 88. All right, well, if I were to estimate 37 times 88, it's to round both factors, so 37 is about 40, 88 is about 90. So to do 40 times 90 is the same as 4 times 9, which is 36, and add two zeros at the end, because this is really 10 times 4 and 10 times 9, so add two zeros at the end, 3,600. So remember to round each of the factors or use compatible numbers. Compatible numbers are easy numbers to work with. All right, the good thing about compatible numbers is you're not necessarily rounding, you're just finding easy numbers to work with. So for number one, I would say 7 is close to 10. And I would say that 396 is close to 400. So 10 times 400 is equal to 4,000. That's 1 4. That's 1 4 with 1, 2, 3 zeros behind it, 4,000. Now, I'm looking at the answer key, and they actually used a slightly different number. They said 7, they kept it the same, times 400. So they basically said, 7's an easy number to work with, so I'm going to use that because it's a compatible number. So 7 times 400 is 2,800. The difference between compatible numbers and rounding is compatible numbers are just easy numbers to work with, where rounding has, asks you to specifically round. It will be very clear on the test what I'm looking for. So for number 2, that's 17 times 63. Let me copy that. 17 times 63. I would say 17 is close to 20, and 63 would round to 60. Well, 2 times 6 is 12. And then there's 2 zeros behind that, so 1,200 or 1,200. I'm going to, let's go down a little bit. We got more room. For number 3, which is 91 times 51. Once again, I apologize for my handwriting. Let's circle that so you don't think it's part of the problem. 91 is close to 90. 51 is close to 50. So 9 times 5 is 45. And add 1 0, 2 zeros to the end of that. 1, 2 zeros. Answer is 4,500. And just to not make the screen any smaller, I'm going to do number 4 down here. So for number 4, we have 45 times 806. Right? So to estimate this product, 45, I would round that to 50. Nice, easy number to work with. 806, I would round that to 800. 800. So what does that get us? Well, 5 times 8 is 40. With 1, 2, 3 zeros behind that, 1, 2, 3 zeros behind that, that estimate would be 40,000. So the only one that was a little weird is number 1 in the answer key. They kept 7 the same and rounded that to 400. So 7 times 400 is 2,800. I used a slightly different method when I first looked at it. I said, oh, 7 is close to 10, and 10 times 400 is 4,000. This is a compatible number because these numbers work well together. This is specifically rounding each to the nearest 10. Right. Hope that helps. All right, now let's look at set C. All right, set C, I'm not in love with the way the book describes it, but I'm going to go over it. All right, so set C wants you to keep track of place values. So so if you were doing this problem, 4 times 249, 4 times 9 ones is 36. So you put the 6 down here, carry the 3 up there. 36 is 3 tens and 6 ones. Well, then you get 4 times 4 tens is 16 tens, plus 16 tens plus 3 tens is equal to 19 tens, which is 109 tens. All right. I really don't like how this describes things. I'm going to describe it, but then I'm going to do these problems my way. Let's go back to my description, or to the description here. They want you to recognize that 4 times 40 is, let's write that down, 4 times 40, let's get my pen, is 160, right? Plus, we already have 30 from 4 times 9 is 36. So basically they're saying, all right, put a 0 there. 6 plus 3 is 9. Bring down your 1. So you end up with a 9 in this place value and a 1 up here because that's really 100. All right. I personally think that this keeping track of this is more complicated than it needs to be. So I'm going to ignore this. I think it's actually makes things more confusing. So I'm going to do it the traditional Lipkovsky tried and true method. All right, 3 times 133. So let's do that. 1 is 3 times 133. All right, for this problem, there is going to be no carrying. 3 times 3 is 9. 3 times the 3 in this place value is 9. And 3 times 1 in this place value is 3. So the answer is 399. For number 2, here I already see that I will have some place values to contend with. So 343 times 5. Okay. 5 times 3 is 15. So I bring the 5 down there, 1 up there. 5 times 4 is 20, plus 1 is 21. So put the 1 down there and the 2 up there. 5 times 3 is 15, plus 2 is 17, or 1,715. In green, I'm going to do number 3, which is 7 times 893. Okay, well, 7 times 3 is 21, carry the 2. 7 times 9 is 63, plus 2 is 65, carry the 6. 7 times 8 is 56, plus 6 is 62, which means the final answer is 6,200, I'm going to make that a comma, not a decimal, 6,251. And finally, number 4, I'm going to do in this space right here, 4 times 1,278. 4 times 8 is 32, carry the 3. 4 times 7 is 28, plus 3 is 31, so I'll put the 1 there, carry the 3 there. 4 times 2 is 8, plus 3 is 11, put the 1 down there and carry the 1. 4 times 1 is 4, plus 1 is 5, so 5,112 is the answer. I think this complicates things to the point where I don't find it useful. And that was, by the way, number 4. All right, moving on to set D. Set D is you can draw arrays to model these. Okay, so this is basically the standard algorithm. What I'm going to do, I'm going to do 1 and 3 with the traditional route, and I'm going to do 2 and 4 with the arrays. So let's look at 1 and number 1 would be 21 times 13. Remember, I could also have written 13 times 21 with the 13 down here, because multiplication is commutative. You could do it in any order. So 1 times 3 is 3. 1 times 1 is 1. Now I have to put a place value 0 holder there, because this isn't really 2 times 3, it's 20 times 3. So 20 times 3 would be 60. We say in short, we'll say, okay, 2 times 3 is 6, but 20 times 3 is 60. And 20 times 1 is 2, but since this is in the tens place, 20 times 10 is 200, which is why the 2 goes there. So our place value is 1 times 3 goes here, 1 times 1 goes here. 2 times 3 is really 20 times 3 is 6 goes in this place value. That's why we use the place value holder here. And then 2 times 1 is 2. Add them together and I get 3, 7, 2, 273 is my answer. All right. For number 2, I said I was going to do that with an array. So we have 34, which is 30 plus 4, and 52, which is 50 and 2. Okay. So what does this mean? It means I have these numbers to multiply. 50 times 3 and 50 times 4, right? So that's the 34 times 50. And then also the 2 at the end, 2 times 30 and 2 times 4. That's where you get the 52 times 34. All right, so this array, the good news about it is the multiplications are easier. The bad news is it takes up more room, more space, all that stuff. So 50 times 30, 5 times 3 is 15 with 2 zeros behind it. 50 times 4, well, 5 times 4 is 20 with 1 0 behind it because there's 1 0 over there. 2 times 30 is 60, which is 2 times 3 is 6 with 1 0 behind it. And 2 times 4 is 8, which is just 8. So now if I add up my place values, my thousands has 1,500. Don't have any more thousands, so I'm going to go to hundreds. Excuse me, 1,500. Hundreds, I have 200. 200. 60, I have right there, 60. And then I'm left with 8. So add it up. 0 plus 0 plus 0 plus 8 is 8. 0 plus 0 plus 6 is 6. 5 plus 2 is 7. And then 1 comes down. So it's 1,768. For the purpose of not losing space, I'm going to erase this to do numbers 2, 3, and 4. Okay, so number 3, I'm going to use the traditional just algorithm, which is 89 times 27. Okay, let's do it. 9 times 7 is 63, carry the 6. 9 times 2 is 18, plus 6 is 24. Put a 0 right there. 8 times 7 is 50, 0. 8 times 7 is, oh, I need to cross that out from before. 8 times 7 is 56, so put a 6 there, carry a 5 in this. And 8 times 2 is 16, plus 5 is 21. All right. Add our little columns downwards. I have 3. 4 plus 6 is 10, so I put a 0 there, carry the 1. 1 plus 2 is 3, plus 1 is 4. It's an ugly 0. Once again, I'm writing with my mouse, not my stylus, which is why everything looks ugly. And this becomes a 2. Nothing to add the 2 to, so I have a 2. So 2,403. And then I'm going to do 78 times 47. I'm going to use an array for that. So 78 would be 70 plus 8. 47 is going to be 40 and 7. When I do it this way, what do I get? All right. 40 times 70, well, 4 times 7 is 28 with 2 zeros behind it. 40 times 8 is 4 times 8 is 32 with 1 0 behind it, so 40 times 8 is 320. 7 times 70, well, 7 times 7 is 49, but there's 1 0 at the end, so 490. And then 7 times 8 is 56. So now I like to add them by using the place value that's biggest first, so that would be 2,800 or 2,800. Plus in the hundreds we have 320 plus 490 plus 490 plus we have 56. So a total of 0 plus 0 plus 0 plus 6 is 6. 0 plus 2 plus 9 is 11, plus 5 is 16, so 6 here, carry the 1. 1 plus 8 is 9, plus 3 is 9 plus 3 is 12, plus 4 is 16, carry the 1, and 1 plus 2 is 3. So the answer to this one is 3,666. That's how you do set D. All right, for set E, all right, remember to regroup if necessary. All right, so they want you to first estimate to see if the answer is reasonable and then calculate the answer, right? I'm going to do that for some, and some of them I won't necessarily do that for. So this is about, well, let's look at number 1. Estimate, this is about 10 times 50. So an estimate, good estimate would be about, well, that would be a 5 with 2 zeros. 500 would be a reasonable estimate. All right, now let's do the actual math for number 1. This would be 9 times 54. 9 times 4 is 36. Carry the 3. Oops, ugly 3. 9 times 5 is 45, plus 3 is 48. So the answer to the first one is 486. For number 2, let's do that in green. 76 times 59. Ugh, this is ugly. I apologize. When you write with your stylus like I do, it's kind of ugly. 76 times 59. All right, 6 times 9 is 54. Put the 4 there, 5 up there. 6 times 5 is 30, plus 5 is 35. All right, next line, we start with a place value block, or place value 0. 7 times 9 is 63, so I put a 3 there, 6 up there. 7 times 5 is 35, plus 6. 35 plus 6 is 41. Add them together, you get 4. You get 8. You get 4. You get 4. So 4,484. All right. I'm going to erase these two to give me some room for the third one. Third one is going to be 407 times 302. So let's erase that. Let's do number 3. Number 3 is 47 times 302. All right, let's do it. 7 times 2 is 14. Carry the 1. 7 times 0 is 0, plus 1 is 1. 7 times 3 is 21, so I'm going to bring down 21. Next, we have to put our place value 0 holder, because this isn't really 4 times 2, it's 40 times 2, so, but I'm going to call it 4 times 2 for the purpose of what we're doing here. 4 times 2 is 8. 4 times 0 is 0. 4 times 3 is 12. So when I add up this column, I get 4. 1 plus 8 is 9. 1 plus 0 is 1. 2 plus 2 is 4. And 1. So 14,000. Let me just check. Yep, 14,194. Same answer I got as before. All right, for the next one, I'm going to use an array just because why not? 800 and, yeah, let's put 32 over here. So this is 30, and this is 2. So 32 here. 871 is 800 plus 70 plus 1. Okay, so I basically have 6 different multiplications to do, and then I got to add all my answers. But it's each individual multiplication is actually pretty easy. It's just putting it all together at the end, adding things up. So 30 times 800. Well, 3 times 8 is 24. And there's 1, 2, 3 zeros behind it. So 1, 2, 3. That's 2,400. Excuse me, not 2,400, 24,000. All right, 30 times 70. Well, 3 times 7 is 21. And then I'm going to put 2 zeros behind that. And 30 times 1. Well, 3 times 1 is 3. And I'm going to put 1 0 behind that, which should make sense that anything times 1 is itself. So 30 times 1 is just 30. 2 times 800. Well, 2 times 16. Sorry, 2 times 8 is 16. But I put 2 zeros behind it because it's not 8, it's 800. 2 times 70 is, well, 2 times 7 is 14, but I put 14. But I put 1 0 behind it. And then, of course, 2 times 1 is 2. So now that I did all these, let's now, let's use blue. Let's start with our largest place value. So I have 24,000 plus in my thousandths, that's my 10,000th place value, plus 2,100 plus 1,600 plus sorry, 140 plus 30 plus 2. So if I add these up, this column is a whole bunch of zeros and a 2, which is 2. This column, which is my 10th place value, is a bunch of zeros, a 4 and a 3, so that's a 7. Next place value is 0 plus 1 is 1, plus 6 is 7, plus 1 is 8. Next place value, which is the thousands, is 2 plus 4 is 6, plus 1 is 7. Put the comma there. And then in the final place value, all I have is a 2, and that gives me 27,000. Hold on a second. Yep, 872. Same answer I got as before. All right. Gonna do the line. Oh, you know what? And let's also, for this one, do a little rounding just to see if our answer makes sense. So this, by the way, is number 4. To round it to see if it makes sense, 32 is close to 30 times 871 is close to 900. Right? So 3 times 9 is 27. And then we have 1, 2, 3 behind it, 3 zeros. 1, 2, 3. So our estimate is 27,000. Our actual answer was 27,872. So both those answers make sense. All right. At this point, I mean, I'm talking 28-minute video. It's still a couple of sets to go. But you know what? Why not? It's a video. You can fast forward if you don't want to watch this. Let's do number 5 and number 6 and then be done. I'll do the traditional route for both of them. 55 times 604. All right, well, 5 times 4 is 20. Carry the 2. 5 times 0 is 0, plus 2 is 2. And then 5 times 6 is 30. Now, in the next place value, I'm going to erase that 2 there, or cross it out. Start here, because this isn't 5 times 4, it's really 50 times 4. So 50 times 4 is equal to 200, so I would put a 0 here. Carry the 2 up there. 5 times 0 is 0, plus 2 is 2. And then 5 times 6 is 30, so I get 30 there. Now, what I want you to notice is this is something I noticed when I was younger and learning to multiply. Um, and I'm going to use what's called the magic pen because it disappears, right? If you kind of see, if I'm multiplying by the same number, what I should see is something that looks like this. These two numbers are the same, and these two numbers are the same, and these two numbers are the same, and these two numbers are the same. I get basically the same digits because I'm multiplying both rows by fives, but it kind of gets shifted one over just because of the place value. So kind of my way of saying, did I multiply right? So 0 plus 0 is 0. 2 plus 0 is 2. 0 plus 2 is 2. 3 plus 0 is 3. And then 3 is by itself, which means the correct answer is 33,220, which matches my little answer key here. And the last one, 4 times 7,133. Okay. By the way, let's estimate first. It's kind of what the instructions are asking us to do. 4 times 7,000, we'd expect the answer to be about 28,000. Now let's see what happens when we actually do. So this is an estimate. Let's do the actual math. 4 times 3, 12. Carry the 1. 4 times 3, 12 plus 1 is 13. Carry the 1. 4 times 1 is 4, plus 1 is 5. 4 times 7 is 28. So the actual answer is 28,532, which is pretty close to our estimate. Once again, this was number 5, and this was number 6. All right, hope that helped. All right, let's talk about set F. All right, so set F, let's read the directions. Draw a picture and write an equation to solve. The length of James's pool is 16 feet. The length of the pool at Wing Park is 4 times as long as the pool is 4 times as long, excuse me. How long is the pool at Wing Park? So they basically draw James's pool and they kind of put 4 of them back to back. So 4 times 16 equals the length of the Wing Park pool. L is 16 times 4, which is 64 feet. The length of Wing Park pool is 64 feet. So we're going to draw pictures to do these problems, okay? And then we're going to do the math. And draw an equation, write an equation, which is, yeah. All right. So the picture, so remember that pictures and equations can help you model. Draw a picture and write an equation to solve. So let's do number 1 first. Alexandra has a collection of 34 dolls. A toy store has 15 times as many dolls as Alexandra. How many dolls does the store have? Well, I'm going to look at it as 34 dolls, right, this way, and 15 this way. All right, 34 by 15. Well, this one, I don't want to draw 34 15 times, and I don't want to draw 15 34 times. So I actually would personally just, this is not a good example for drawing a picture. It really isn't. Even the answer key doesn't have a picture. Ugh, this is a good example. 4 groups of 16. I'm not going to draw 15 groups of 34. That's silly. All right, I'm just going to do the math here. So 15 times 34. 15 times 34. 4 times 5 is 20. Carry the 2. 5 times 3 is 15, plus 2 is 17. Put a 0 in this place value. 1 times 4 is 4. 1 times 3 is 3. Add it together. You get 0. 7 plus 4 is 11. Carry the 1. 1 plus 1 is 2. Plus 3 is 5. So it's 510 dolls, right? The other way of thinking about it is the equation way is 34 times 15 equals D for the number of dolls. That's the equation you have to write. Because if they ask you to write an equation, what numbers am I multiplying? And when I multiply them, I get D for the number of dolls. All right. Thankfully, we're up to this one right here, set F. All right. A store received a shipment of 37 TVs valued at $625. What is the total value of the shipment? Well, let's go with the equation first because that's reasonable. 37 times 625, $625. 37 times 625 equals the total value. I'll call that V. That's the equation that they want you to write. I'm actually going to use the array method to do this. So I'm going to call 625 600 plus 20 plus 5. And I'm going to call 37 30 plus 7. Okay? So now, if I basically do this piece by piece, and you don't have to do it, you could use the traditional, multiplying like I have for most problems, but let's just see how this works. 3 times 6 is 18 with 1, 2, 3 zeros behind it, so 1800. 3 times 20 is 6 with 1, 2 zeros behind it. 3 times 5 is 15 with 1 zero behind that. 7 times 600 is 42. 1, 2 zeros behind that. 7 times 20 is 7 times 2 is 14 with 1 zero behind that. And 5 times 7 is 35. So now that we have all our pieces, let's add together. Our biggest place value is 10 thousandths, so 18,000. This is so much harder to do without a stylus, so I apologize for my ugly handwriting. Then in the thousands, we have 4,200. Then in the hundreds, we have 600. Plus we have 140. Plus we have 150. And then finally we have 35. Add it all together. 0 plus 0 plus 0 plus 0 plus 0 plus 5 is 5. 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus 4 plus 5 is 9 plus 3 is 12, so put a 2 there. Carry the 1. 1 plus 0 is 1, plus 2 is 3, plus 6 is 9, plus 1 is 10, plus 1 is 11. Put a 1 there. Carry the 1. 1 plus 8 is 9, plus 4. 9 plus 4 is 13. Comma's going to come down there. 13, carry the 1. 1 plus 1 is 2. So the total value of the shipment is $23,125. In this case, we are counting money, so that would be dollars. $23,125. And finally, the last part. You need to carefully consider all parts of the argument. All right. Think about how these questions help you critique the reasoning of others. What questions can I ask to understand other people's thinking? Are there mistakes in other people's thinking? All right. So let's see if there's any mistakes in this person's thinking. Remember, you need to carefully consider all parts of an argument. Sarah has 214 bags of beads. Each bag has enough beads for 22 bracelets. She estimates that 200 bags times 20 beads is 4,000. There are enough beads for at least 4,000 bracelets. Well, let's see. Here's what happened. Can you critique her reasoning? I'm actually going to type because I think it's going to be easier than writing. So she went from 214 down to 200, and she went for each bag has 22 bracelets. 22 bracelets down to 20. And she said, I'm going to multiply 200 times 20, which I think is reasonable, but that's going to give me 4, excuse me, 4 with 1, 2, 3 zeros behind it. It's going to give me 4,000 bracelets. And she says there are enough beads, right, to make 4,000 bracelets. All right. Well, let's talk about this. If there's more than 200 bags, and each bag is going to make 22 bracelets, and she rounded down in each case, that means the number that she got was underestimating the number of bracelets. Which means, are there enough beads to make 4,000 bracelets? Yeah, she underestimated. So, yes, she will have enough. She will, yeah, yes, she will have enough for at least 4,000 bracelets. All right. Anyway, I hope all this helped. I know this was a long video, but it's to help you fast forward.